Today I am going to solve a problem. This is move zeros, and the problem statement is given an integer array nums, and we have to move all these zeros present in this nums array input array to the end of it while maintaining the relative order of the non-zero elements. Note is given here that we have to do this in place without making a copy of the array. So as of now, this particular problem is saying that whatever the nums array we are having, the input array, in that whatever the number of zeros are present, we have to place them at the end. We have to move all those zeros at the end of the array, and whatever the non-zero elements are present here, we have to maintain the relative order of those non-zero elements. The order should not be altered as it is shown in this output of the array given. So now firstly I will discuss the brute force approach with using which we can solve this problem in the simplest manner, and then we will move ahead that how we can optimize that particular approach, or we can go with the optimal approach in order to solve, like as it is given here that we have to do this in place. So as of now, let me explain that how I can solve this problem in the simplest manner possible. Here is the example I have taken. This is the array which is of size 5 and having these elements 0, 1, 0, 3, 12. See, when we will move these all zeros at the end, the resultant array will look like this, that all the number of zeros present in this 0 and this 0, they are available at the end of the indices of this array. So zeros are moved at the end. Now the first approach or the first intuition which we can make, that we have to make a particular array in a form where all the non-zero elements will be present at the start, and automatically the zeros will be present at the end. So in order to do that, what we can take the approach that we can simply use two pointers, like in this brute force approach, like what I will do, I will take another array, or we can say an extra array, in which we will keep two pointers. One will be at the 0th index and another will be at the last index. And what we will do, we will simply traverse through this particular array, whatever the input array we are given with. We will take a pointer I, and starting from here till the end, we will check the elements. If we found any particular element to be non-zero, then we will keep that element at the start of the index. Wherever the first pointer is pointing at the temporary array, and if we found any zero, then we will keep at the end index, that is the kth pointer which is pointing, the second pointer. So let me explain it more clearly. Here are the two arrays I have taken. This is simply an input array which I have. This is the input array which I am having from the example, and this is going to be the extra array, or I can say the temporary array, which I will be using as part of keeping our elements and in the final result. So I will start with this particular thing, that I will take a variable which will be traversing the input array, and I will take two another pointers which will be pointing in the temporary array. Now what I will do, I will simply traverse this entire array with the help of this with this pointer I. So what it will it will check the indexes, elements, that if this element is a non-zero element, I will keep it at jth index, and simply I will increment this j. And then if any element is found to be a non-zero zero element, then it will be kept at the kth index. Okay, so if I found any non-zero element, it will be kept at jth index, and if any zero is found, it will be kept at kth index. And simultaneously, we will be doing this thing, that if any element comes at jth index, j will be incremented forward to take the next non-zero element, and if any zero comes at kth index, then that particular k will be decremented, and in order to take the another zero here there. So let me walk you through this particular approach. Firstly, this I seen this I is at the 0th index, and it will see that is this a non-zero element. So it will see that no, it is a 0. So simply take this 0 and keep it at kth index, where the k is pointing. So 0 will come here, and then k will be decremented here in order to take next 0. And in order to traverse, I will move ahead. Again, it will see that is this a non-zero element. So yes, this is a non-zero element, and this element will be coming at jth index, where j is pointing. So here 1 will come, and then j will be incremented further in order to take the next non-zero element. Then in order to traverse in the array, I will move ahead again. Here it will check, is this a non-zero element? No, this is not a non-zero element, this is 0. So keep it at kth index, where k is pointing. 0 will come here, and simply k will be decremented back in order to take another 0. Then I will move ahead. It will check, is this a non-zero element? Yes, this is a non-zero element, so keep it at jth index. 3 will come here, and then j will move ahead. Now in order to traverse in this array, I will move ahead. I will check, is this a non-zero element? Yes, this is a non-zero element, so it will keep at jth index where j is pointing, and then j will move ahead. And this is how, in order to traverse, I will again move ahead where condition goes false and loop will be ended. Now we are able to see that this is a final array which is looking like, where all the zeros which were present in this original array, these two zeros are present at the end. So these, all the zeros present in the input array, they moved at the end. So this is how this approach is going to work. And let me walk you through the code of this particular approach. So let's come here in this editor. So what we will do, simply, firstly I will take this size of this array, nums at this end, nums dot size. And now what we will do, what we have to do here, we have to simply take another array in order to keep these elements. So I will take another array, let's say temp. So vector int temp, and I will take the size as same of the nums. And now what we have to do, we have to keep two pointers here, one at this 0th index and one at this last index. So I will take int j equal to 0 and int k equal to n minus 1, that is at last index. Now what we have to do, we have to simply traverse in this input array. So in order to do that, I will use a loop for int I equal to 0, I less than n, I plus plus, and now I have to traverse. So now while traversing, what I have to check, if this element is a non-zero element, then I will keep that element at kth, sorry, this first pointer jth index, and then increment j. So first condition is that if this nums of I found as a non-zero element, and in that case what I will do, I will take that element and keep at the first pointer wherever j is pointing right now. So it will be like that temp of j will be holding that element, and from this nums of I, okay, and simply we will have to increment this j in order to take next non-zero element. Now in else part, obviously the element, if it is a non-zero, it will be 0. So we will simply take that element and keep at temp of k from nums of I. We will take that 0 and keep it temp of k, and then simply decrement this k in order to take next 0. This is how the things will be working. Now when we will be completed with this temp array is having a particular result which we want, that all the zeros move at the end, we will simply take this temporary array and copy it inside the nums array for int I equal to 0, I less than n, I plus plus, and then we will simply take this element from temp of I inside this nums of I. So every time taking any element from temp of I and keeping it at nums of I, corresponding elements. So this is how this code will work. Firstly we will take a extra array, and then we will take two pointers there, and every time we will check if any element we found as non-zero, it will be kept in temp of j, and then j will be incremented, and if we found an element as 0, it will be kept in the temp of k, and k will be decremented, and simply we will then copy this entire array in our original array. So let me take the input. What are the inputs we have to take? Firstly we have to take the size, so let me take the size as 5, and then we also have to take the the size of this number of elements in this array. So let me take 0 1 0 3 12 as we are given in the example, and then yes, let me run this code now. So yes, it is giving the desired result that all the zeros are moved at the end here. Okay, so this was the code all about in this brute force approach. Now let me let us see the time complexity of this. So if we see the time complexity of this code is for this particular loop, it is running for n, means it is visiting every element once. So the time complexity for this, we take, if we see the first loop, so it is taking big O of n, and then yes, again it is checking the entire array, means from temporary array to nums array, it is copying the elements. So it is again taking this big O of n. Like for the first loop it is taking n, and for the second loop it is again taking n, so it is like big O of 2n. So yes, if we see the time complexity, as this constant is ignored, so time complexity is big O of n. But if we see the space complexity, And space complexity is obviously the n, because we have used the extra space which is of size n, the temporary array which we have used here. So this is taking the space, and because of this it is taking the space, so it is not that much efficient. So yes, we have to go with another some better approach in which we can use do this thing in place, as we have already given in the problem statement. But before going to that, see, there are different approaches which we can call as the brute force approaches only because they are using the extra space. Likewise, similar to this particular approach, like somewhat different, another variant of this brute force approach is like for that I have taken the code uh, prior only, that this particular approach is using let me keep it here. Okay, so now coming with this particular approach, this is again another variant of the brute force approach. Variant brute force approach. So this is another one in which we can see that it is again using the another array. So in this, what happening is that we are taking another array, and then we are using a particular concept of counter, where what we will do, we will simply take this array. Let me take this input array here firstly. So this is the input array we are having. Now in this, what we will do is we will again take this another array in order to keep our result. So this is the array, and now in this, what we will do is we will simply take this particular elements. We will run a loop, and we will check these particular elements using I. And while traversing, we will check if any element we found is non-zero. Then we will simply take that particular element and we will push in this temp array. So this is our temp array, and we will like if we have seen that this is a non-zero element, we will push it inside this. If we saw this non-zero element, we will push it inside there. And if we see this non-zero element, we will push in this temp. Now at the end, what we will do, we are also simultaneously keeping a counter of 0, that if I am finding any particular 0 there while traversing, then I will increase the counter for that count 0. And at the end, when I will come that till now I am having these particular elements in the relative order as we wanted, and after that, whatever the counter value is, we will run a while loop for that, and till the counter is not becoming equal to 0, we will simply push the zeros in this particular temp at till the point the counter is not becoming equal to 0. So simultaneously, we will be also counting this, decrementing this count 0, and as the point where the count 0 becomes equal to 0, so yes, this particular loop will be ended as this condition goes false. So this is how we are using this particular approach, using the counting the number of zeros. So we will firstly keep all the non-zero elements in this temp array, and then we will start pushing the zeros until the counter becomes 0, as we have already made a particular counter with some number of zeros which were present in original array. So this is all about this approach. Again, if we see the time complexity of this, so in this, if we see this particular loop is running from 0 to n minus 1, visiting every element once. So again, the time complexity is big O of n for now. So the time complexity for this is, as of now, it is n. And if we see this particular loop, so whatever the number of zeros were present, let's say here the number of zeros were 2. So we can see that number of zeros were 2. So in this case, it is running for like 2 times, we can see, because the counter values for the zeros is 2. So it will be running for firstly for let's say the counter values firstly 2. So it will run for it, and it will push 1 0, then counter will be decremented to 1. Again it will check, so it will be, the condition will be true, so again the 1 0 will be pushed, and then counter becomes 0. So this is how this particular loop is running for the number of times this count, whatever the number of zeros are in this count 0 values there. So in this case it is 2, so it will be running for 2 times, and it basically depends whatever the number of zeros, whatever the value will be of count 0. So based on that, and it can be like maximum, we see that in this particular whatever the original array we will be having, it may be possible that all are the number of zeros. Okay, so in that case simply that particular number will be coming here. So if we see overall, then the time complexity is going to be big O of n. And now in this case also, if we see the space complexity, so space complexity is coming to be again n, because we are using this extra array now. So these are there can be different approaches we can solve, but in that case we are using the extra array. So now uh, in order to come with the better approach, we will come to the optimal solution. We can see the better approach, or we can see the optimal one. So let's come here and check how we can solve this particular problem without using any extra space. So firstly, let me take this input array here. So this is the input array I am having. Now what I will do with this, see, in the problem statement they had given us that we have to solve this in place without making a copy of the array. So we will have to do things in place inside this array itself. So firstly, in order to explain this, I will take this array and I will make any of the changes. Like what I can do is I can simply take two pointers. I can simply take the two pointers here. So the one pointer which I will take, that will be used in order to place the next non-zero element. So here the I which I have used is the I pointer which I have used is this particular I will be what the work will be of this. The work of this particular I will be to take the next non-zero element. Okay, whatever the next non-zero element will be coming, that will be kept at this ith index, wherever this I is pointing to. And what is the work of this j? So work of this j is to track, means to just scan this particular array. Scanning this particular array means, yes, let me write here. To scan the array means to traverse the array basically. Okay, so what it is doing, it will simply check the array and it will see any of the element. If it is found as non-zero, then it will be keeping it at ith index where I will be pointing. And if it found any zero, then it will simply move ahead, because that should not be placed at ith index. And at the end we will see that how the number of zeros will be moving at the end. So let me explain this, how it will work. So this is the array. Now firstly I is pointing here and then j is pointing here. So firstly j is checking that is this a non-zero element? No, this is a zero. So it will not do anything, it will simply move ahead. Then it will check, is this a non-zero element? Yes, this is a non-zero element. So then what it will do, it will take this element and keep it at, it will basically replace this particular element whatever present. It will take that element and keep at ith pointer where I is pointing. So here comes 1, and now I will be incremented further to take next non-zero element. And then as part of this traversing, j will move ahead. It will check, is this a non-zero element? No, this is a zero. So simply move ahead. So no need to do anything. Is this a non-zero element? Yes, this is a non-zero element. So wherever I is pointing, take that element and keep it there. So 3 comes here, and then I will move ahead to take the next non-zero element. In order to traverse, j will move ahead. It will see that is this a non-zero element? Yes, this is a non-zero element. So take this element and keep at the ith pointer where I is pointing. So 12 comes here, and then I will come here to take the next non-zero element. Now j moves ahead to traverse in this array, but the condition goes false, and at this point the loop will be ended. Now the fact is, the main important thing comes here. Whatever the last index I is pointing, starting from that index till the end of the array, we have to keep all the zeros. We have to basically replace the number of elements, whatever they are present, and those indexes we have to replace them with zeros. So I, okay, so the thing is, the last index where I is pointing, starting from that ith index till the end of the array, what we are going to do, whatever the nums of I is, it means whatever the values are there for nums of I, we will replace them with zeros. So as this I is ended here, so starting from this particular index, we will go to last index and place and keep them all as zero. So last index where the I is pointing, starting from that ith index, we will till the end of the array we will keep nums of I as 0. So here we will keep the 0, here we will keep the 0. So now we can see that this is the final array which we want, this is the final result which we want. Now to better understand this, let's go into the code editor and write the code here. Now firstly I will take simply this size of this num. So nums of size will be saved inside n. Now what we have to do, this is the input array we have, and firstly we will take the pointers here. Firstly I will start with I equal to 0, because it will be pointing at 0th index where the non-zero element is going to come. Then j will be traversing obviously, so what I will do, int j equal to 0, j less than n, j plus plus, and what it will do, it will simply check for nums of j, and if it finds that this nums of j is not equal to 0, then what it will do, it will take that nums of j and keep at nums of I. So this will be nums of I. So this is nums of I, and that particular nums of j is coming here. And obviously for the next non-zero element to take, I will be incremented ahead. And when this particular loop gets ended, so what it will do, it will simply check for non-zero element. It will, if it founds, it will keep it at nums of I and simply increment I ahead. And if it found the 0, then no problem, this j will simply be incremented ahead. So this is the particular scenario here. And at the end, what we have checked, that whatever the I is pointing at last index. Now we will again run a loop for int. Let's say this time I will take this int k, and I will point it at I index where I is pointing, and this k less than n, and this k plus plus. Now what will it do? K will be pointing here where the I is pointing. Okay, so k will be pointing here where this I will be pointing, and starting from this index till the last index, it will place all them as zeros. So this nums of k will be zeros. This is how the code will look like. And if we see the okay, firstly let this run. It's going to work or not. It will work. Okay, so this got accepted, and let me try to submit this. Yes, submitted. So now let's see the time complexity of this. So if we see this loop, this for loop is running from 0 to n minus 1. So the time complexity for this particular taking this loop into consideration, the time complexity will be big O of n. Time complexity is going to be big O of n. And also if we see this particular loop, so it is running from I to n minus 1, starting from this index to this. It means wherever the I is last ended, till from that index to the end of the array, all zeros will be present there. So now what we can see here, from I to n, it means we are having the size n, and if we subtract this I here, so like the size we are having 5 minus this I is ended at which index, 0 1 2 3, third index. So basically 2 times this particular loop is running. So we can say that yes, n minus I, obviously 2 times this loop run for this and this. So we can say that it is like let me take this here. Yes, plus is okay, so plus big O of n minus I can say. So more precisely if we say, then yes, the like average time complexity if we see, so it is going to be big O of n only. So the time complexity is big O of n. And if we see the space complexity, so since we have done all these things in place only, we have not used any extra space, so the space complexity is going to be constant. This is what we want as an as a part of the optimal approach or the better approach. So yes, we've done this particular problem.